Hello, everyone. Good evening. So, I would like to welcome you all to Tech Talks by CMS. Now, to start off with, let me give you guys a quick introduction about Tech Talks by CMS. So, we started this somewhere in 2012. It's been over a decade ago since we started this Tech Talk. And from the beginning, we've always invited people interested in learning about technology to our office. And, we've hosted the event there. Unfortunately, for the past 2 years, because of the pandemic, we've not been able to uh, host any event as such. But right now, we have most of our engineers working from home, and we're currently following a hybrid model. So we thought, let's have Tech Talks by CMS online. And today we would be talking about React, and we would be covering a lot of areas under today's topic. We have our tech lead Tharindu who would take you through this. So we would be focusing on areas like, why should you choose React? What problems can you solve using React? And, Tharindu would also share with you some hands-on examples on this area. So without wasting a lot of time, I would like to call upon Tharindu. Hi, Tharindu.
Hi, hello.
Yeah, over to you, Tharindu.
Thank you, Shihab. Uh, so let me share my screen actually. Yeah. Can you guys see my screen? Can you confirm that you can see my screen?
Yeah, we can.
Okay. Thank you. So good evening, everyone. Thank you very much for tuning in. In this session, I'm going to talk about React. But instead of taking a more practical approach, talking about components and state and all that technical, all that practical stuff, I decided to talk about some theoretical stuff like what goes under the hood, or like what React does, what it is, and then like what type of problems that React solves. So that is the effort from me from this session. So there will be more sessions like this of React, but not just React. There will be more sessions by me about more backend technologies, design patterns, like microservice architectures, and so on. So in this session, I will be focusing on more theoretical side of React, or should you use React for your next project, yeah, and so on. So let me introduce myself a little bit before we get started. So my name is Tharindu. I'm a tech lead at CMS. So I work for this Norwegian company called Never Offside. It's a sport tech company. Uh, so we are building a digital platform there, focusing on sports clubs, mainly football, ice hockey, and so on. So what we are doing is we are letting the sports clubs to communicate with their affiliated companies, their sponsors, and well, mostly other fans of their football club or other sports clubs. So we're using various technologies, different cutting edge latest technologies. Just to name a few, for backend, we use a microservice architecture. So we heavily focus on Node.js, and then we use Nest.js as the framework for Node.js. And we use TypeScript. And then for front end, we mainly use React. And then also we develop a mobile application. For that, we use React Native. And other than that, for the infrastructure, then the orchestration, we use GCP and also Kubernetes with the help of Docker. So that is a little bit about me and what we do at Never Offside. Mm, and then if you guys have any questions in this session, during this session, please write them in the chat. I will try to get them as the time permits, but just in case if I can't, uh, I can like email you the answer so we can communicate through a different source. Yeah. Okay. before we get started, I have a small disclaimer. So I am assuming that you are familiar with React, like at least you have the knowledge of essentials, and then JavaScript in general, and then some knowledge of document object model is actually nice as well. You don't need to know like too much detail into it, but just some essential knowledge will be good to follow on. But still, I'll try to explain some of these concepts to my best knowledge. So these are the topics. These are the topics that I'm planning on discussing in this session. So at first, I'll talk about the document object model, and then what sort of problem that we have with the document object model as we have it right now. And then I'll talk about the solution. In this case, it's React. Obviously, you have more solutions, more full-fledged framework, but in this session, I'm going to talk about React. So the solution is for this session is React. And then I'll talk about some main concepts of React. So in this case, elements, components, and what components are. We'll look at how React would see elements, components, and then what a component instance is. And then to the meat of React, I would say virtual DOM, uh, and then virtual DOM, and then how it works. That is reconciliation, how virtual DOM works with React, and then how it updates the actual DOM, and then how we will go. So reconciliation after that, maybe you have heard of this one, maybe you have not. Diffing algorithm. That is also a core component of I would say it actually works alongside with virtual DOM to perform the reconciliation. So we'll talk about that. And then I'll briefly talk about the rendering, which is one of the important concepts uh, in React, because as you may know, React is called a library, not a framework. We'll see why. I'm just gonna not gonna go too deep into rendering, but like we'll just see what rendering is, then we'll get an overview of it. And then to sum it up at the end of the session, I'll talk about the state as well. Yeah. So let's get started. So the document object model. So as we know, it's actually a sort of a HTML document, you could say. It is structured as a tree structure in a hierarchy. So as you can see, you can have a parent, and then the parent can have a children. One of the children could have another child, which makes that child a parent, and so on. So it's in a hierarchy. And also, document object model is pretty much an API. So uh, each node or each element uh, of the document object model represent an HTML element pretty much. Div, you have p tags and so on. So it also acts as a bridge or interface between HTML and JavaScript. Thus, you can use JavaScript to actually directly manipulate nodes in the document object model. For an example, you could use get elements by ID, and then with these new JS syntaxes, new JS updates, you can use query selector with the ES6 features, and so on. So that is the document object model in a nutshell. And then let's discuss the problem that we have with the document object model. So the current workflow of a DOM, or like let's say like when you try to update an HTML document, when we try to change a node to like when you try to add some text content, or like changing the input of a like changing the state of an input. So when that happens, what DOM does is like, because DOM is actually first it has the HTML, so it is rendered by the rendering engine. So if you're using Google Chrome for an example, the rendering engine would be WebKit. So it is constructed by the rendering engine at first with the HTML. So HTML will be passed to the browser. But like the way it happens is first it passes the HTML element, and then it passes the CSS of CSS that are assigned to those HTML element as well. And then it will apply those CSS rules or CSS configurations to those proper HTML inputs as or HTML elements actually. So that what happens every time do you do a change to the DOM. That's what happens every time you do a change to the DOM. So imagine this is just one element. Imagine like simultaneously you change or simultaneously a few elements are changed. So this will occur every time an element is changed. So as you can see, the problem is updating the DOM is actually expensive. It costs you a lot of resources because it's going to pass the HTML, it's going to pass the CSS, and it's going to apply the CSS. Sorry. And every time this happens, the entire DOM will be repainted to the browser. So if your application have high user interaction, if your application needs high flexibility, and then if a lot of elements are changed at a time, so then updating the DOM will be really expensive. So it's inefficient. That's why I mentioned here keyword is updating the DOM is inefficient. So the rendering process will take a lot. So let's see a potential solution here. So we could say nowadays we have a lot of libraries, or nowadays we have a lot of frameworks, but React can also solve this problem. So React is just a JavaScript library. It lets you create reusable UI components, like highly available uh, reusable components, I would say. So it is developed by Facebook. So as I said before, if your front end UIs that they need high user interaction, or like they change frequently, or require a lot of flexibility, or like if you're adding a lot of UI contents on the fly dynamically, then in that case you can consider using React. Okay, so before we go to the document virtual DOM, I would like to talk about some of these core concepts of React and what makes React's building blocks pretty much. So first we have React elements. Before I mentioned, like, I hope that you guys are a little bit familiar with React. Uh, so because like I'm not going to talk too much detail into like what a component is, then what JSX is. Uh, so hopefully you guys are following along. So basically, React element is, if you have used it before, it's just a function that returns JSX like so. So you can see in this first figure, I have written some code down. So this is what we see. This is what we do. Like we just write functions, and then like we just return JSX. That is what pretty much the gist of it. But in React, with the template renderer compiler, this will be converted into this type of object, as you can see down below. So don't worry about all these properties, all these keys here, all these values here. Just focus on the type and then props for now. So this is the object that will be converted to by React as soon as we define a component, or in this case, React element. So let's dig deep. Okay, so first we have the type, it is div. So in this case, our parent or root element is a div element. So the type will be div. And then props. So this is a good concept in React. So you can pass immutable values to your components. We'll talk about props in a bit. Uh, but in this case, you should probably be familiar with these props by now. But as you can see, class name, it is an attribute for, like, divs, but it is passed as a prop as well. But at the same time, this text content, React Talk text content, is passed as the children. So as you can see, uh, we have different type of props here. Uh, so this actually what happens when you define this simple React element inside React. What React is this object. Okay. Uh, so back in the day, if you have been using React for a while now, maybe you have used React create element function before. Nowadays you don't have to be, because it will be implied as soon as React is loaded. But back in the day, you would have to define create element, and inside that you would have to define this function like so. So what happens is, uh, when when the React converts this object from this function into this object, inside, like behind the scenes, this function create element function will be called. So this is just one function. Imagine, like, we have only one div element. Inside that we have props. That's pretty much it. So if we had another div element instead of React Talk text element, if we had one more div element, then what happens is, focus on this last code snippet, React.create element div, and then inside the div, props will be passed, but instead of React Talk at the last property, it will be another React.create element, and inside the div, inside that div will be taken. So that's why I mentioned here, JSX will be converted to many React elements, because in this case we only have one div element, but inside the div element, if we had more div elements, so at first React create element part, and then instead of this React Tech Talk, it will be the other div element, like so. But I just wanted to mention it because that's what happens inside React when the JSX is converted into that object. So and then we have the React component. So if you guys are using React component, then you guys are familiar with components, of course. So nowadays everyone is like using class functional components with hooks, but back in the day we use class components as well. Uh, so both components take props. This is one of the inputs that components take. So I mentioned briefly about props in the previous slide. So props are pretty much like when you wanna pass down a value or state from your parent component to your child component, then you can use props. So props are mutable. So whenever the parent component's props are changed, so does the uh, child components value as well, because it's immutable and they're linked. Uh, so the component is also what we see is like pretty much earlier I talked about React elements. So in React component, what we are doing is we are like it's just a element tree pretty much. It returns an element tree. So we have more than one element actually. So I just uh, put here what React sees, like we see is a like uh, as in like a React element tree, but inside React it sees as this kind of object. So the type is actually function. That's the key here. The type is actually a function. What it happens is like if it is a functional component, if it is a functional component, React will actually call directly with its props. But if it is a class components, then what happens is like React will first create an instance of the component, and then by accessing that instance, if you guys are familiar with class components, you know you guys have to define or use the render function. Otherwise, it's not going to work out. Otherwise, it will throw an error to use a render function. That's how it will be painted to the browser. It will be that's how we will render this function. So if you are using class components, you have to use a render function. So through this instance, it will actually call the render function instead of calling it directly. That way you can see the component, or you can render the component. So the other part is component instance. So don't get it twisted. Like the previously I mentioned about an instance, this one is like completely different. This component instance is quite complex. Uh, so I mentioned here, React actually keeps track of all the components. The way it does is by creating an instance of each component. So each component has a state or initial state, and also has a life cycle. Uh, so if you guys are using functional components now, nowadays, then we have the state. So we can access that state by using a hook called useState hook. Also, we can access the life cycles by using the useEffect hook. Uh, but it's different for a class component. But in class components, you can actually directly access the state by using this keyword, because the instance will be created from that component. So through this keyword, it is referring to the current referring component. So this means the current component. So the current state, you will be able to access the current state by using this keyword. And also in class components, you have these predefined lifecycle hooks, not really lifecycle hooks, lifecycle methods. So you can access them by component did mount, like you can access them like such as component did mount, component will mount, and so on. But nowadays everyone is like taking more of a practical approach with React hooks and stuff. Like I'm not gonna talk about too much into the class components here, but the mainly I want you to focus on this component instance, as is like React keeps track of all these components by creating instance of each component. And then we'll talk about the virtual DOM. So a virtual DOM is like, as I mentioned before, is actually the meat in React. Uh, so the virtual DOM, the way it works, and then what it is like it is not exactly a, someone would argue it's a copy of the actual DOM. It's not quite. It has all the necessary functionalities of DOM, but not all. So that's why I mentioned here it's an abstraction of actual DOM. So it's an in-memory lightweight object. So since it is in-memory object, it's actually quite fast, not like the actual DOM. So it's quite fast. And then React manages the abstraction of the actual DOM as virtual DOM. So it's also is a tree data structure as the same as DOM. But the thing is, here's the catch. Instead of rendering changes to the actual DOM straight away, the changes will be applied to the virtual DOM first. We'll see how that it does it, React does it. But the important thing is, as soon as a change happens, or like as soon as a state of a component changes, it does not update the actual DOM, which would defeat the purpose. It would go back to the actual DOM in that case. So it will just update the virtual DOM first. And then React will actually update the actual DOM when the time comes. in batches. So it's not gonna update the actual DOM every time a change occurs, or like every time the virtual DOM changes. It will do, it will update, it will update the actual DOM in batches, thus improves the efficiency. So rendering of the virtual DOM, like how the virtual DOM is created. So before we talked about React elements, React components mainly. So what we do is what we do there is pretty much we define JSX and we return JSX. So that's pretty much the structure that we want, right? Like we define JSX pretty much. And then we have this template compiler, JSX template compiler, and then template compiler, after compiling all the JSX, it will build the virtual DOM. At first, it will just be repainted once. At first, like, the initial phase, the template compiler has to build the virtual DOM, like, at once. So entire virtual DOM will be created. And then so if you are familiar with React, so for an example, if you are building an application with React app tool or bundler, you usually import React, and also you import another tool called React DOM, and then you use the render method. So this is the renderer that I was actually referring to earlier, which we will talk about in a few. So that renderer function will actually create the virtual DOM. So template compiler will build the virtual DOM and then the structure, and the renderer will actually create the virtual DOM and it will render it. That's how we see the components that we write. So renderer plays a big part here. Let's talk about the reconciliation and also what virtual DOM does, and then how it works and how we would improve the efficiency and solve the problem that we have with the DOM. So the reconciliation is pretty much what virtual DOM does. It's, as the name would suggest, reconciliation, like self-explanatory. So for an example, let's see the state of a component has changed. As soon as it does, React will detect it. And what it does is, right now, when you are changing a component of a React, the initial virtual DOM is rendered already. So we have the initial virtual DOM with its initial state. So as soon as the state has changed of a component, what React does is it will create a new copy of the virtual DOM, but with that change. So we have the current virtual DOM, we have another copy of the virtual DOM, but with that change, right? So like some people, like, some people might think the virtual, as soon as a change happens, the virtual DOM will compare it with the actual DOM, but that's not what happens. This is one of the crucial part to understand. It will actually create another virtual DOM with that change, and then we have two different virtual DOMs, the current one and then the latest virtual DOM copy with the latest change. And then it compares the current virtual DOM with the actual copy, with the copy of the virtual DOM, to actually figure out what's the difference, which node has changed. So it does by using an algorithm called Diffing algorithm. That's how Diffing algorithm comes into play. Earlier I mentioned about the Diffing algorithm, but at that time I'm pretty sure like it didn't make any sense if you didn't know about it. But now it's sort of making sense, right? So what it does is, like, React actually compares the current virtual DOM and then the copy of the latest virtual DOM, and then it figures out the difference, which node has changed, which node caused the state to change. It figures it out by using the differentiation. It will figure it out by using the Diffin algorithm. And then React will actually decide when to update the actual DOM. But the thing is, it does not like as soon as it detects which which nodes have changed, it does not update the actual DOM straight away. So you will have something like a queue. So in this queue, you have all these changes, and then React will decide when to update which. So that's why I mentioned earlier, React will update the actual DOM in batches to improve the performance and also the efficiency. So as I mentioned here, so actual DOM will not be updated frequently, but only at a period of time. Because of that, actual DOM will not be changed every single time, but at a period of time. Actual DOM will not be repainted every single time a change occurs. So maybe like now you're realizing earlier the actual DOM actually changes every time a change occurs, and then it will be repainted the entire document object model or HTML document in this case. But that is not the case with virtual DOM. Virtual DOM actually like with React, it will actually update the actual DOM periodically. Okay, so I have a small illustration or like a small animation of how the reconciliation process works. So we have the original DOM here, and we have the virtual DOM here. At first, they both be the same because the JSX template compiler will build, and then the renderer will render the virtual DOM. At first, the original DOM and virtual DOM is pretty much the same. And then imagine we have a change on one of these nodes in the virtual DOM. So this node is going to be changed. That means the state of this component, this is a component pretty much. Virtual DOM is a component. Well, not virtual DOM. This is a component that is represented as this virtual DOM here. So in this element, in the component has changed. So that means the state of the component has changed, which will cause a render uh, to create a virtual DOM here with the copy of it. So we have the virtual DOM, and then we have the copy of the virtual DOM, but with the change. So as soon as this happens, React, by using the Diffing algorithm, it will try to figure out which node that has been changed. So we'll try to figure out by using these two virtual DOMs, and it will figure out which node has changed. As soon as it does, actually this is just one iteration. The original DOM updation will not happen straight away, but just to demonstrate here, let's just assume like this is after a while, after like a few has changed, like when the React decides whether to update the original DOM or not. Let's say in this case, React decides to update the original DOM. So as soon as it figures out which one has changed, and then React will update the original DOM sometime later in batches, like so. So this is sort of like the reconciliation process. Just wanted to give you like a brief overview of it. Uh, we could actually talk about reconciliation in much detail. This is just an overview in this session, just to get you guys familiarized with it, yeah, just in case if you like, didn't hear about it or didn't know much about it. Okay, I'm just going to briefly talk about, since we talked about reconciliation, like who does the reconciliation? I know it's React, but React is not just one object. It has collection of tools and objects, in this case, in the engine. So it's a tool as well. React uses this reconciliation engine called, well, actually used to. React used to use this stack reconcilier as the reconciliation engine in earlier version of React. Nowadays we're using React 17 mostly, but this is before 16, but we had problems with it. So I'm just going to briefly talk about this, not going to go too much detail into it. But if you are actually interested in these reconciliation engines and stuff, you could actually do your own researches, or you could go to actually the React official page and then documentation. They have a good article about this as well. So this reconciliation engine was actually synchronous because of this behavior. So synchronous means it's just like it's going asking like a sequential. You have to wait till the first one is done to go to the second one. So it's pretty much kind of like the thread is blocked till the first one is done. You have to wait till the first one is done to get the second done. So the updates and then like creating virtual DOMs and then copy of the virtual DOM, the entire reconciliation process is actually synchronous. So you have to wait till first one is done to go to the second one, like so. So I mentioned here it's behaved like a stack. That's actually why it's called stack reconcilier, because of its nature, synchronous nature. So it behaved like a stack. Uh, so that's why I mentioned here tasks couldn't be interrupted and had to wait till the stack was empty, because stack is empty. Then you had to wait till the stack was empty uh, to proceed to the other tasks pretty much. And then React introduced the React Fiber. That is the new reconciliation engine we use nowadays. So it enables the incremental rendering of virtual DOM because it is asynchronous. So now you don't have to wait. You can do a lot of. I mean, now React Fiber can do a lot of stuff because it is asynchronous. So work, in this case, I mentioned work. Let's see, work is like updating the DOM, or like the as soon as a state changes, like the reconciliation process. Pretty much, this is the work can be like updating the DOM, or like virtual DOM, and then like virtual DOM updating the DOM. Let's see that. So because of its nature, of asynchronous nature, it can split work into chunks and then also prioritizes work. So this would go first and then this would go later on. But in the stack reconcilier, that was not possible. It would add like a stack. But in this case, this one actually can prioritize work. So it can actually post work to resume it later. So it can do some other stuff. So you don't have to wait till something is done. If something is more important than this one, the React can post that work. Like for an example, updating the other actual DOM, it could update some other element before that. So during the reconciliation, if something were to get cancelled, then actually it can abroad work as well if it is not needed. And also, I mentioned here two phases, but I'm going to talk about these phases in the state section. So I'm going to leave it here. So that is pretty much reconciliation and reconciliation engines. Uh, just didn't want to go too much deep into it. Uh, like just want to give you an overview, so maybe you can do your own research. Just want you to guys to be aware of these reconciliation engines. Okay, and then we have the Diffing algorithm. If you guys are familiar with big O notation, time complexity and all that stuff, because this Diffin algorithm is kind of complex, but it solves the problem actually like uh, combining with React, of course. It solves the problem. uh, let's see what the problem is actually. So okay, first let's see the Diffin algorithm. So I mentioned in the reconciliation process, React uses the Diffin algorithm to see which node has changed and then like how to update it. So let's see how it does it. So Diffin algorithm, in order to work with Diffin algorithm, React actually does some assumptions or some or like some use cases. It checks some use cases when differentiating two virtual DOMs. At first, it checks like for a component, like if the node that has changed is the root element. So in this code snippet, actually this is the same component, but the first one is the one that has been changed in the second one. So first one we have the section as the root, and then the second one we have the div as the root. So in that case, what React does is by using the different algorithm, it would discard the first one or like pretty much tear down the previous tree along with its current state. And it will rebuild the tree with the new div as the root. And then it will actually update. In this case, it's a typo. It's not the actual DOM. In this case, it will like first update the virtual DOM. And then later on actually eventually it will actually update the actual DOM. But what happens is like the first root element with the section will be discarded, and then div component will be repainted to the actual DOM. So that is the first one. If the root element has changed, it doesn't matter. It's not going to go too much into it. It will just rebuild the whole thing with the new one. And then the second assumption or second use case is if a property or attribute has changed. So in this case, the first one is text bold, the class name, and then second one is text semi-bold. So in this case, React knows where it has changed. It will just do the update of this class name portion or attribute and attribute class name portion, and it will just keep the instance as it is, just change the attribute. So like easy there. Like it's like it's really easy to comprehend what is going on there. But the third assumption, this is the one, this is the most important one. If you have been using React, I mean, I'm pretty sure you guys have rendered lists. So sometimes, like if you're new to React and when you're trying to render a list by using like a map function or what have you, you might see this warning saying like it's not an error. The application is not going to crash. It's going to work, but you see this error in the console saying you need to define a key, as in like a prop called key, in order to make it better. Otherwise, you might see some different results. So what you do is like you just define a key, and then like you go along with it. You just get rid of the boarding and then you go along with it. But what happens is if you do not provide a key in this code snippet, there is no key. So in this case, the first unordered list, the first li is GraphQL text node, but the second one after it has changed, it's React. So it's not GraphQL anymore. The first li, it's React. So in this case, what usually React does is like it compares the positions. So at first, the first one first li is GraphQL. Now the second one, first li is React. So since you have not defined a key to each li, React doesn't know down the line which one has changed again. So what it does is like it will actually re-render the whole thing again. So which is not what we need. It will actually decrease the performance or efficiency. So in order to prevent that from happening, what we do is like we actually provide a key. So in this case, as soon as we pass a key, React knows how to detect by using the different algorithm, and it will just change the position. In this case, the key, let's see the key number one. Let's say this GraphQL's ID is one, and then like we can pass the key to one. It has to be something unique. But also, I need to address this issue. Sometimes when you are like mapping through or looping through this list, sometimes you can pass the index as the key as well. it actually makes the warning goes away. But the thing is like uh, the warning goes away, but the problem still exists because as soon as the list grows, the ID changes. So the first one's first ID and the second one's first ID can be two different things. So in that case, it's still React would face the same problem, but you would not get the warning because you have defined a key. So passing the index from that map is not ideal in some cases, but in some cases it might work. But if you want to add like in this case, for an example, index one would be first index one or index zero would be GraphQL. But in this case, second one, index zero would be React. So there's two different things. So React might do the same thing, even though you have provided keys. React might do the same thing by rendering the whole list. So always define a key that does not change. So usually when you are rendering a list, you're pretty much getting a list from a backend, right? So usually they have some sort of a unique identifier, like you have ID or like, I don't know, product ID, something, task ID or something unique that never changes. Use that instead of using the index as well, just to improve the performance, or actually actually leverage the partners of, or like power of React. So like just keep that in mind when you render some list next time. Okay, so and then now we have the rendering. So React is actually called a library, not a framework. So someone might argue because like it has, React router, we have like Redux, but those are not actually first party libraries for React. React is pretty much a library that lets you build reusable UI components. That's pretty much it. So here I have mentioned React defines the elements and components, but it also uses the Diffing algorithm, and it actually is able to detect the changes. But that is pretty much it. But it does not take care of the rendering process. That's why we use React DOM's renderer function to render. Because like if you can remember, when you are using or when we are initiating a React project, you import the renderer function from React DOM, not from React DOM. So and then you actually pass the main or root element into that renderer function. So that is one of the reasons why React is actually just a library, not a full-fledged framework, if you will. So uh, renderer actually plays the big part. It takes care of a lot of information, a lot of important tasks, in important tasks. So then you might wonder like, how do they work together? So remember, like in the React DOM, and you call the renderer function and you pass the first root element of React. In this case, it could be index component or app component, what have you. But uh, that is where the connection happens. So every time something and a state changes and all that stuff, the renderer and React will communicate with each other to keep it up to date, keep keep it up. So renderer is the one actually performing the reconciliation here. And also tree generation, because I mentioned here, when we get start like as soon as I got started, I mentioned when we got to virtual DOM, how the virtual DOM is built. The JSX will be compiled by the template compiler, and then renderer will actually create the virtual DOM. So that's why I mentioned here tree generation. That is pretty much what I meant by that. And also this reconciliation process. The diffing part is obviously, of course, taken care of by React, but this reconciliation process will be taken care of by uh, the renderer. So like not gonna go too much deep into rendering. Uh, just for your information, you can create your own rendering. Just do some research and then like try to find a custom renderer. You can create your own rendering if you want to go too deep into it. But the rendering is actually, I would say, a session of its own, because state and all that stuff will be taken care of by the rendering process. And in that case, now we have come to the end of this session. So at the end, I want to talk about the state, like in brief. So uh, state can be considered in simpler terms the memory of a component, right? It can be considered as the memory of a component. So every time a state of a component changes, it will trigger re-renders. At first, the initial render will be like the when it is loaded, when it is mounted, and after that, every render will be a re-render because it has been rendered once. And every time the state changes, it will re-render. And as soon as the component, like as soon as the state changes, it will re-render. The way it's gonna re-render is by communicating with the renderer, because renderer is taking care of the rendering process. Okay. So if you are using functional components, nowadays everyone is using functional components, then you have this use state hook. So you can change the state by using the use state hook, but in class components, you have this set state function. You can use that to actually change the state. So I, I briefly mentioned about a queue earlier because that's how it does the badge updates, or React does the badge updates. So what happens is you have this queue, and then every time the state changes, that change will be added to the queue. And then React will decide by using another algorithm, let's say, React will decide when to change or when to change the actual DOM. And then by within this queue, it will decide which badge should go next, and so on and so on. So when a badge is picked, and then yeah, when pretty much a badge is picked, the way it is updated is the following two rendering processes. Earlier I was talking about two rendering processes when I was talking about the reconciliation engine. I skipped that part there, so I'm going to talk about it right now. So when a state changes, how it updates the actual DOM at the end is in two phases or two steps. First, we have the renderer phase. In the renderer phase, it's actually asynchronous. The behavior is asynchronous. Actually, the new update, React will calculate the update and actually create a list of effects. In this case, effects is like pretty much a DOM mutation. DOM mutation is an effect. So it will calculate the updates, but pretty much the new state is the update that I'm talking about, like the differ from the previous state. And then it will actually create a list of effects. This is the first effect, the second effect, like so. And then the second phase is obviously synchronous. So it will do one by one sequentially. And then it will start the updating process, and then updates will be applied to the actual DOM. So that is the state. I didn't say what, like state is, or pretty much like what state is. I guess I briefly mentioned the state is the memory of the component. But since like this, like in this session, I assumed like you knew something about React. So state is like pretty much in the essentials. Like if you are using React, you know what state is and what state does. Okay, so that is pretty much the end of this session. So thank you. If you guys are still here with me, thank you very much for participating. Please stay tuned. Stay tuned. I'm actually doing more sessions about React. I'm actually not abandoning React. I'm doing more advanced concepts of React later on in the future, and also I will be doing more sessions with different topics. As I mentioned before I started the session. Please stay tuned for that. When it happens, you will be notified. So if you guys are interested. So thank you very much for participating and listening to me. So have a nice day. Thank you.
Thank you, Tharindu, for your time. And if you guys will be sharing the recording of this session on our website in a couple of days. And I hope to see you guys on our next session as well. And also with regards to the question and answers, if you guys have any questions that you would like Tharindu to reply, I would drop my email on the chat. So if there's any questions with regards to this session, please share your questions with me and I will see that, we get back to you soon.